So our new topic today is convection, and we're looking at two demonstrations. Both of these can be found linked in the Schoology assignment. What you're looking at is what's changing about the motion of the materials in the beakers based on their temperature. We've got one hot and one cold. So when you draw and describe what is happening in each one, make sure you use some color and make sure you use arrows, right? That's really going to add to the motion. So you can go back to those videos, complete them, and then return back to this video. What we're really thinking about is how those particles are moving based on their change in temperature. And I think in middle school you guys talked a lot about the differences between solid, liquid, and gas. And we know that each one of those phases can be found traditionally at different temperatures and therefore different characteristics. Our solid is typically the cooler, the gas is typically the warmer, and so they act differently because of those changes in temperatures and changes in their composition. So what we're looking at specifically here is what are the particles doing because of the change in temperature. So we're thinking specifically about the spacing of those particles for both warm and cool examples. It does tell us here to do 10 particles. We're going to up it a little bit and go to 20 in our example today. So color coding is always helpful when we do these. So I'm going to use my red highlighter for warm, and I want to place my 20 particles here, showing the spacing that happens when you heat an object up. So when you heat up an object, the particles get more excited, they move around more, and they space out. So I want to make sure when I draw in my warm diagram, I keep those particles spaced out or expanded away from each other, any of those. Whereas cooler particles, they don't have as much energy, they're slowing down, they are becoming more compact over time. So when again I draw my 20 particles, I want to make sure that they are more condensed. And that's because they don't have as much energy. They've cooled down. I always think about the visual of like kids at a bus stop huddled together. Not a lot of energy, not a lot of motion, staying close. Whereas here, summertime, it's warm, we're running around, we got more energy, a lot more space with our particles here. So with those spacings, we can now get an idea on how that space impacts density. So we have an option down here, circle up what type of density we would have. Density is simply looking at how compact the particles are. So here, in our warm scenario where they're more spaced out, this is what we call a low density composition. The particles are more spaced out, less dense, whereas here they're more compact together. They have a higher level of compactness or a higher density. That density is directly related to the motion of the object. Typically, when we have a high dense object or a high density object, it's going to sink downward. It's essentially heavier, whereas the low density object rises up, it's essentially lighter. So what we're thinking about in this bottom table here is pulling everything together. If a material is known as high density, what will that mean in terms of temperature? Is it warm or cool? its motion, is it rising or sinking, and what's its particle spacing like, far apart or close together. So you're simply going to have 3 bullet points here, maybe a little diagramming, listing out one of these 2 keywords: warm, cool, rising, sinking, far apart, close together. And whatever characteristics we get for high density, we should be able to go opposite over here with low density. Once you've got your table filled in, you can use that information to work through this idea of convection currents. Now we're noticing a flow happening between the 2 different temperatures. It's not just a simple increase, decrease, rise or fall, always cold, always cool, warm, but it's this flow, it's this full cycle or cell that we see happening all over the place in nature. So here you have a guided description. Here you're putting it into your own words, describing how and why the air is moving the way it is in terms of motion, temperature, and density. So you're thinking again about how it's moving, why it's moving, and then a couple connections here. And all of this should lead you to be working on that learning target number 7.